Hello, my name is Papia. In this problem, we have a demand function. It's given by P is equal to 600 minus 5x. We have to compute the price elasticity of demand at x equals 60. That's the quantity demand. And then we have to figure out if the demand is elastic, inelastic, or of unit elasticity. And finally, we have to graph the revenue function using a graphing utility and then find the intervals of elasticity and inelasticity. Okay, so let's start with computing the price elasticity of demand. So recall that we use the notation eta for it, and the formula is it's P over x divided by dP dx, where P is the demand function. So notice we have to compute the derivative of this function. So let's do that first. So let's see. What is dP dx? P is 600 minus 5x, so you're taking the derivative. Well, derivative of 600 is just a constant, so it's 0. And then for negative 5x, the derivative is just negative 5. So that is dP dx. Okay, now plug everything in. So in the numerator, we have P over x. P is 600 minus 5x divided by x. And the denominator, we have dP dx, which we just computed, is negative 5. All right, see there are two different fractions here. Let's make it into one fraction. And you know how to do that. You keep the numerator fraction as it is. And the denominator fraction gets flipped. Now, what is the fraction in the denominator? It's negative 5. That means it's negative 5 divided by 1. So you flip it, it becomes 1 over negative 5. Therefore, we have 600 minus 5x divided by negative 5x. Okay, so this is the price elasticity of demand, but we have to figure out what is eta when x is 60. So when x is 60, we have eta is equal to 600 minus 5 times 60 divided by negative 5 times 60. Okay, so let's quickly simplify this. We have 600 minus 5 times 60, so that's 300, divided by negative 5 times 60, so another 300. Therefore, we get 600 minus 300, that's 300, divided by negative 300, which is equal to negative 1. So eta is negative 1. All right, so using that fact, let's go to the next part. We have to figure out if this demand is elastic, inelastic, or of unit elasticity at x equals 60. Well, look at eta. Okay, take the absolute value. That's absolute value of negative 1, which is 1. So we know if absolute of eta is 1, that means it's unit elasticity. Okay, so that's our answer here. All right, for the last part, we have to graph the revenue function using a graphing utility. Well, what is the revenue function? So revenue function is usually denoted by R, and it is P times X. So price per demand times the number of demand. Well, P is 600 minus 5x. Multiply with x, you get your revenue function 600x minus 5x squared. So let's graph it. Okay, so graph the function 600x minus 5x squared, and we want to find the intervals of elasticity and inelasticity. So recall that demand is elastic when revenue is increasing, which means we have to figure out in which interval the revenue is increasing, and it will be inelastic when revenue is decreasing. Okay, so let's graph r of x and figure out where the function is increasing and decreasing. Okay, you see the graph. Now, also we consider revenue to be positive, so only look at above x-axis. Okay, you can use the zero feature in the graphing utility. And you figure out that the graph will cross x-axis at 0 and at 120, as you can see. All right, now see, where is the revenue increasing? Well, it's increasing starting at 0 till it gets to the maximum point. And where is that maximum? Well, guess what? It's at x equals 60. That's where the function is maximum. Therefore, revenue is increasing between 0 to 60. All right, where is it decreasing? Well, starting from 60 all the way up to 120. So that's where it's decreasing. So, intervals of elasticity is 0 to 60 and inelasticity will be 60 to 120. That completes the problem. Thank you.